There we go. Okay, cool. Well, thanks for the introduction, Robert. That was great. I'm happy to be here. It is my first time at Tapestry, but I'm excited to sort of learn from all of you guys. So I'm an academic. I'm not a journalist. I'm not a graphic designer. But I use a lot of insights from narrative and data stories in my work. So I'm calling this talk Using Storytelling Patterns to Make Data Relatable. Because if I think about my research in data storytelling, usually I'm trying to find these patterns that are very sort of fundamental and then build tools around them. So if I had to define data storytelling, I'd call it a way of making complex information relatable or sharing a perspective on data. At least in terms that apply to my research, that's what I'm interested in, is how we can do this so that data is accessible to more people. And so Enrico's talk about tools kind of sets up my talk. Trina's talk about making information relatable or familiar also does. So in my field, information visualization, storytelling is something that some people are really excited about, but other people are sort of ambivalent about because they think, oh, this is sort of fuzzy and imprecise. We can't really reason about it. It's not scientific. And so some people sort of stay away from it. My reaction to the fact that data storytelling is new and we don't know a lot yet is that that's a challenge for me because I want to formalize things. I want to pull out these patterns and talk about them in ways that we can actually sort of measure and operationalize them so that we can build tools. So the goal of a lot of my work is to formalize these different storytelling or narrative patterns and then create tools that use these as well as automation or semi-automated suggestions in order to help people either design data stories or consume unfamiliar data. So the method that I do this, or the method that I use to do this is often to start with a cognitive challenge about data. So there's a lot of aspects of data that are very sort of inherent or fundamental, but that are also really hard to think about. Things like uncertainty and probability, or scientific processes and scientific findings. We want to understand these despite scientific jargon. Another example would be scales of measurement we can't quite wrap our heads around. So I'll often start by identifying these challenges and then looking in fields like cognitive psychology to see what we know about how we can help people overcome these challenges. But I also look a lot at expert communicators or storytellers, people like data journalists, science journalists, graphic designers, because I think these people actually have a lot of implicit knowledge about how to explain complex concepts in really understandable ways. And so I'll look at what they do and try to pull out design principles or criteria that they're using or different types of patterns, and then work to formalize those and build tools around them. So what I wanted to do with the talk today is give you an example of a few projects that sort of have this pattern where we're trying to kind of identify patterns in storytelling with data and then make those a little more formal and build tools around them. So the first challenge that I'll talk about is unfamiliar measurements. So people encounter measurements in news articles and other places, but they can't quite grasp the magnitude in a way that makes sense. So I'll talk about how we're building tools to re-express measurements in terms of familiar objects automatically. And then the second problem I'll talk about is helping people make sense of many visualizations at once. Because most data stories are of containing a set of data where we might have related visualizations, which are different views or facets of our data set. So how do we present these to people in an order or using a structure that makes the information easy for them to grasp? So let's jump into this first problem. So people encounter measurements all the time when they're surfing the web, for instance, reading news articles, reading data reports, looking at data visualizations. But a lot of times we can't quite grasp how big a measurement is. And there's various reasons for this. So here on the left, I have an article that's talking about the volume of Earth relative to the volume of Mercury. And one problem I have here is that these numbers are huge, and I just don't think about numbers that big, so I really can't grasp those. Another problem is that the unit's unfamiliar. So on the right, I have an article that's talking about an earthquake in Spain, but they refer to kilometers for distance, and that's not a measure or a unit I know, and so I'm left with sort of a very fuzzy idea of that measurement. And similarly, the measure itself can be unfamiliar. I don't often think about volumes in my everyday life. I don't often think about areas. But one thing that graphic designers and journalists will often do is re-express these measurements in terms of familiar objects. So here we could say that the volume of Mercury relative to Earth would be like comparing the volume of a ping pong ball to that of 20 bowling balls. Or for a New York-based audience, we could say that 21 acres is about half the size of Grand Central Station. And this gives our audience a way to connect personally with information that's otherwise hard to grasp. And we also see visual re-expressions of these complex measurements called concrete scales. So here we're taking measurement analogies, and then we're using graphic design principles to sort of make them visualizations, which are quite engaging to people. So on the left, we see just a graphic depiction of the size of a Starbucks Trento latte compared to the size of a human stomach to make the point that it's just way too big. And then we also see sort of slightly more complicated ways to generate analogies and visualize them. On the right, we're seeing different byte unit sizes for measuring the amount of digital information. This is a very abstract measure, but we can map it to distances, which is a physical measure that we can experience in everyday life, and it gives us a way to understand the differences between these different byte sizes. So I'm interested in these types of representations. I think they're really cool and helpful, but the problem I noticed is that right now it takes a lot of work to create something like this. Even to create a measurement analogy and put it in text in an article takes time. We have to go out and find measurement data online. We have to know something about our audience and what they consider to be familiar objects. And so I was curious if I could develop a solution that would make it easier to generate these types of things so we could sort of benefit from them in more context. So this is the question I wanted to ask. Could I build automatic tools that generate these things given an input measurement? So the way we went about this is starting by thinking about what's a good criteria for a measurement analogy. So we can look at a bunch of examples, but until we can actually sort of articulate what makes an analogy good and what makes the objects in an analogy good, then it's hard to go about building a system. Once we have criteria, we can go out and gather or scrape data sets of objects and then their attributes or their measurements. And then finally, once we have that data set, we could develop re-expression functions that sort of model these different criteria of good re-expression. So I'll walk you through this process briefly that we used. So we started by thinking about, well, what makes a good object for a measurement analogy? And so we looked at a bunch of examples, looked at some work in cognitive psych, and found that there's a few different properties that you sort of have to have. So the object should be recognizable to people. It should be familiar. And ideally, the measure itself is familiar. So the weight of that object is familiar if you're using it to re-express a weight. Objects should also be concrete. They need to have physical measures if we're going to use them in concrete scales. And finally, they should be countable. The quantity should be clear simply from the name or from a picture. So I could tell you something like, well, 1 pound is about equal to the weight of sand, but that's not very helpful. On the other hand, something like 1 pound is equal to the weight of an hourglass is a little bit better because it's a unit. And then a final property that is good for objects used in these analogies is that we want them to have low variance in the measure that we're interested in. So if I want to re-express something like a weight or a volume or a diameter, a tennis ball would be a great example because no matter whether my tennis balls are made by Spalding or Wilson, they all tend to have these very rigid properties. So we wanted to take these criteria and then go out and create a database of such objects. But the first thing that we needed to do is figure out how are we going to represent these objects in a database? Do we just sort of pull out the names of objects, or could we have a better representation? And so to find a representation of basic objects, sort of categories of objects, we looked to WordNet. So if you're not familiar with it, WordNet is a semantic network. It's basically a graph of different distinct concepts. It's very useful in a lot of natural language processing and AI and many other applications. And in this case, the WordNet nodes in the graph are called synsets, and they're a good representation of objects that's a little more descriptive than just the name of the object. So a synset would be something like a canoe. A canoe is a more specific example of a synset, like a boat or a small boat, as it's called. And a more specific instance of a canoe would be a dugout canoe. And so WordNet gives us these adjective phrases and things like the definition of these concepts for all different categories of objects. So we wanted to use WordNet synsets in order to go out and query for data to get measurements, basically. But we needed to choose which part of WordNet to use, because WordNet has objects, but it also has things like processes or concepts that are more abstract. And so we found that because we wanted objects that were concrete and countable, we could just focus on this branch of the WordNet tree, which is artifacts. So an artifact is defined in WordNet as a man-made object taken as a whole. So it's concrete, it's countable, which is great for our purposes. So we took these sin sets, each one represented by a couple adjectives, and then we queried, using scripts to automate this process, different places where we knew we could find measurement data for these objects. So Amazon's product database, Wikipedia, or DBpedia and Freebase, and we gathered a bunch of instances of each of these general types of objects, like tennis balls or pipes or canoes. We are extracting the measurements from each of these instances that we're getting, so we're pulling out things like weights, heights, lengths, volumes, and widths, and creating this big data set of objects where we have the general type of object, we have many instances of each, and we know the measurements. But recall that one criteria we want, if we're generating measurement analogies, is that the objects need to be familiar to people. And while WordNet has a lot of familiar objects, it also has some objects that are not very familiar, things like potentiometers and spirographs, which most people are not familiar with. So to get familiarity as sort of a measure that we could apply to each object in our database, we basically showed crowd workers images of all of these objects that we'd collected data for and asked them to rank them in terms of how familiar they are, considering that we wanted to use them in measurement analogies. So we get a familiarity score for each object. And then our last step to generate measurement analogies, using all this data, is to define these mathematical functions that we're going to use, sort of simple equations that allow us to take in an input measurement and output re-expression in terms of some number of familiar objects. For example, 4.3 kilograms is about equal to 5.6 microphones worth of weight. So again, we want to use the familiarity of the object now that we have that score. We haven't really used it yet, so that's one criteria that will appear in our equation. We also want to take account of the variance, and we want to look for objects with low variance. And now that we have a bunch of instances of each object that we've collected by scraping data from Amazon, et cetera, we can actually calculate variance and use that in our equation. And then finally, there's another property of good measurement analogies overall, which relates to this multiplicative factor that we see. So in 5.6 microphones, 5.6 is the multiplier. It's what we have to times the weight of a microphone by in order to get our input of 4.53 kilograms. And we looked into research in number sense, so how do people understand numbers and their magnitudes? And what we found is that people are actually pretty bad at understanding or reasoning accurately about numbers unless they're in this very narrow range, which is basically 1 to 10. So as numbers get bigger than 10 or smaller than 1, people just get really imprecise in trying to mentally think about them. So we wanted to make sure that our analogies tried to keep the multiplier in this range so that we could avoid things like 4.53 kilograms is equal to 943 pens, because nobody really carries that many pens around. So we have sort of simple mathematical equations that basically have three different terms. One represents the familiarity of the object, where we're prioritizing very familiar objects. Another represents variance. We want to penalize objects with high variance. And finally, we have a score and a weight for the multiplier, and we want to penalize multipliers that are not between 1 and 10. So we can compute this equation for each object in our database, given an input measurement, and we get out a measurement re-expression. So the next step was then to take this tool, this function that would give us these analogies, and make them sort of more engaging by using visualization to do that. And so we created some interactive reader applications where we had our measurement analogy generator on the back end, and we had an application that could tag measurements in news articles, and then on demand a user could click on any measurement and they could see a graphical re-expression of that measurement. So here we're just showing the top 5 or so reunitizations for this measurement. We do this for a number of different measurements, different measures themselves, like weight, height, volume, et cetera, all the things in our database. And we even did some things like proportional analogies, where suddenly your input is 2 measurements, and you want to see a re-expression of the relative size of the first to the second. So a user of this application can click on 2 measurements using of the same measure. These are both volumes. And then they get a proportional analogy, saying, for instance, 1,000 cubic meters compared to 12 million cubic meters is like comparing the volume of a water bottle to that of a hot tub. And here we're using what we know about these concepts or these objects in WordNet, so we can look at how similar the two concepts are in the WordNet graph, how close they are together, and make sure that our proportional analogies return objects that are not only the right proportion relationship, but also seem similar to one another. These are both volumes of water. So this was kind of an exciting project to show that we could actually generate these analogies in a way that we could scale to many, many readers. We don't necessarily need the graphic designer to go out and find the data anymore. But there's some types of measurements that I realized were not really so easy to re-express with the tools that we'd made. And a lot of those are spatial measurements. So things like distances and areas are better expressed with located measurements and located objects, like landmarks. For example, a journalist might write that 4.3 miles is about the distance between the Empire State Building and the Brooklyn Bridge. And so here we have two landmarks and the distance between them, and this is a nice re-expression. But one problem is that it's a nice re-expression if we're in New York City. Then we can understand it. We walk by these things perhaps on a daily basis. But if I was in Detroit, I might want a different re-expression of that same number to help me understand. I might want to hear, for instance, that this is about the distance between the Packard plant and Greektown. And so I started thinking about, well, could we develop tools that could generate not only analogies for spatial measurements using located objects like landmarks, but also personalize those for the user. So again, I sort of looked at research that's been done in psychology, and in this case, in how people understand space. So I looked at research on spatial mental models. It turns out landmarks are very good as objects for these types of analogies because they're these very memorable objects in our cognitive maps. So as we're trying to navigate a space, we're relying on landmarks typically. And I also learned that a landmark can be significant to someone for a few different reasons. It could be personally significant. For instance, the Starbucks that I stop at daily means a lot to me, but probably not to many other people. But they can also be generally or culturally significant. So the Space Needle in Seattle is significant to a lot of people as a symbol of Seattle, even if they're not living there. So this was sort of two criteria that I wanted to take into account in tools that could generate personalized spatial analogies. And the first one, personal familiarity, modeling this in a way that we could actually automate an application to take it into account is really challenging. So we sort of looked around at what types of cues we could use about a user in order to sort of guess at what landmarks are personally familiar. And we learned that proximity to a landmark is actually a really good predictor of how familiar you are to that landmark. So this is based on research that says, for instance, that our mental models are way more detailed in the places where we spend a lot of time, like our home or our workplace, and much less detailed outside that region. And we can also accurately estimate distances in experiments that have been done when those distances are things like, from our house to the nearest gas station. We can't do it as well when they're further across town. So proximity is a good proxy for personal familiarity. And so what we did is take a similar approach as we did for the general object analogies, but this time we have a different database. This time we scraped a bunch of data on landmarks in the US. So we started with Yelp. Yelp gives us a bunch of landmarks, and then we can go to other resources like OpenStreetMap and pull out things like spatial properties of those landmarks. So where they're located, the area, et cetera. We want to be able to model general familiarity as well, because that's also important. And so here we thought about, well, what's a good sort of data set that could give us a signal of how culturally or generally familiar a landmark is? And so for this, we looked at Flickr data. So we can access basically counts of all Flickr photos using different keywords. And so we look for the names of these landmarks, and we basically take as their familiarity a score which is based on how many Flickr users tag photos with the name of that landmark, and so that gives us sort of a measure of general familiarity. So we have this database, and then our input is similar. We're going to take a measurement that we want to re-express. But in this case, we're also going to take some information about the user, which will allow us to calculate proximity. So we take their point location, and our applications can detect that, or they could give us a place that they're familiar with. And then again, we just have an equation that has a term for these different parts or criteria that are important, the proximity from the user and the between the user and the landmark, which we calculate, and then we have a weight that applies to each term, general familiarity, and then finally, again, we're penalizing multipliers if they're outside this thinkable range of numbers. And so here we again created applications that could allow people to get this type of context on demand. So here our application can either detect where you are in the world, just using IP lookup, or you can enter an address that you're really familiar with. Whoops. Let me play the video. This video goes a little fast, so I'm going to try to pause it. So they enter their information if they'd like, and then as they're browsing the web, our application is basically tagging measurements such as distances and areas, and we're also tagging names of locations automatically. And then a user can basically click on any of these measurements, like an area or a distance, and they see a locator map up at the top, but then at the bottom, they see sort of a zoomed-in view of the area landmark that we're using and that we're predicting is familiar to them. So I live in Seattle, and so it's telling me that 4,700 acres is about 14 times the size of a park near me. So we can do this for distances as well, but we can also do it for things like names of countries. So I could click on a country name that I'm not familiar with, and it will superimpose the area of that country on top of where I live, which is Washington. And similarly, people can click on multiple point locations in an article, which we're also tagging, and then they can get a distance re-expression. So they see the original point locations in the top map, and then they see an analogous distance that's familiar to them at the bottom. So we were excited about this project for various reasons. I think in particular because we can automatically kind of figure out enough about a user that we can give them personalized context for data as they're reading news articles or browsing the web. So we started with this sort of very powerful but simple design pattern of analogies for measurements, and then thought about criteria, what makes them good, and how could we operationalize these criteria, and that allowed us to just then develop these simple automated functions that actually work pretty well for a number of inputs. So that's one project that I wanted to show you to sort of give a sense of what I mean by these design patterns. So I now want to move to another project, which is a little different. Again, I'm going to figure out sort of design patterns that are kind of fundamental to storytelling. But in this second project, rather than relying on outside resources and scraping a bunch of data and modeling things using semantic networks like WordNet, I'm simply going to be thinking about narrative patterns and how they apply to the data that I start with. And so the problem here is how do we present a set of visualizations in a linear sequence that makes sense to people? So this applies to a lot of data stories, and in particular, what we in visualization, narrative visualization. These are often made in the media. Probably a lot of you guys are designing these types of visualizations, and often they're composed of multiple views of a data set, each showing a different part of that data, but in a linear sequence. So here we have just sort of an interactive slideshow where the designers had to think about what order do I put the data in, what data do I want to show, and then how do I structure this. And if we think about sequence in data storytelling, we might begin to realize, well, there are certain patterns we can use, like chronology, which is very common. But there's a lot that we still don't know, I noticed, as I started to look through these types of visualizations. So this example is kind of old, but I like it. And it does use chronology to walk the user through different types of economic recessions and economic booms. And so we're sort of proceeding through time in a very kind of predictable way. But then when we get to the end of this visualization, the author breaks from that type of sequence and instead shows the Great Depression. So they're jumping back in time. And now they're using sort of a compare-contrast type of structure because the Great Depression is so much bigger than any other recession we've seen. So I'm interested, when I started this work, in figuring out what are these different types of transitions or sequences that we can use. And because I'm often interested in modeling things and building tools as the final result, what makes a good sequence for a set of visualizations? What can I actually pull out in terms of design principles and criteria? So an implicit question in this one is this assumption that some sequences are going to be better than others. And so that's kind of what I expected. But again, I sort of looked at the literature outside of InfoVis, because in InfoVis, we still don't know a lot about data stories. So I looked at how people study narratives in narrative psychology, for instance, and decision-making. And I found a lot of evidence that sequence is incredibly important when you're presenting information. So one study that I liked, some researchers basically had a mock court trial, and so they divided the mock jury into two different groups, and one group saw the witness testimonies in one order, and the other group saw the same exact witness testimonies, but in a different order, and the two juries came to different verdicts. Similarly, I'd done a little bit of work with looking at showing people multiple views of the same data, so I was showing them maps and then asking them to interpret the clusters in the data, and even if I only showed them two visualizations and I swapped the order, they would come to different interpretations. So sequence is important, and there's a lot of people that have sort of theories in narrative psychology and decision-making about why sequence is important. And so it turns out that the sequence we present things in sort of changes the stories that we naturally construct in our head as we try to explain that information to ourselves. So whenever we're experiencing a stream of information, we're kind of narrating spontaneously and making comparisons and connections between adjacent pieces of information. So if you change the sequence, people have to tell themselves different stories to make it make sense. And so you get these different interpretations. So I wanted to design effective sequences. Wasn't sure how I would do this yet, but I knew that it was important. I did look to research in InfoVis as well, which is my field. And we do talk about sequence sometimes as visualization researchers, but we usually talk about the discovery order. So I'm an analyst. I'm trying to find things out about data. And so I might construct a number of views in a tool like Tableau or using R. And we can talk about different operations I've taken from one view to the next, like filtering or deriving new measures, but it's all about sort of finding the insight in the first place. And we care about this. Sometimes you want to communicate how you found out some insight in your data to a collaborator, and we call this provenance. How did I get to this result? But what I noted or felt was that discovery order, even if we think about that, it's not going to be the same as presentation order, because a lot of times when you're first working with data and trying to discover things, you go off on sort of a lot of tangents, and you probably don't want to show those to your audience. So there was no sort of clear guidelines on presentation order. So that's what I wanted to provide as a first step in this work. And so this is kind of a hard question, though. I know sequence is important. I'm not sure how, though, we should create effective sequences. And so I decided that I would look at what expert designers and journalists are doing when they create these sequenced visualization-based stories. So I collected a bunch of things like interactive slideshows and scrollable visualizations, animated videos, analysis presentations. All of these have like an explicit sequence that the author has chosen. And I looked at each individual transition from one visualization to the next in these stories and tried to figure out what's the reason, or how can I define this transition. So this led basically to a vocabulary of different types of transitions that I observed across multiple visualizations. So we can have things like dialogue transitions, where one visualization poses a question, another one provides the answer. Causal transitions are really common. We show in one view the cause, in the second the effect. Temporal transitions, we've talked about. Hierarchy-based transitions of various types, like adding filters from one visualization to the next, drilling down from an overview or aggregating the data at a different level. And then I found what I called comparative data transitions. So here, from one visualization to the next, we're holding everything constant, but we're either changing the dimension, which I call the dimension walk, or we're changing the measure, the dependent variable. And finally, there's different types of spatial transitions I noted, things like moving from east to west across a map in a visualization. So I was curious about sort of how important these different transitions were. And so some of them I saw quite frequently. In fact, about 90% of all stories included a temporal sequence. And so this suggested to me that this is a very important type of sequence. Similarly, dimension walks, where you're just changing the population or the independent variable and keeping all else constant, were very common. This one is showing us just graduation rates, but changing the demographic that we're looking at. And measure walks were also really common. So here we're similarly keeping everything constant, but we're changing the dependent variables. So we're here seeing data on people in the UK for different statistics like marriage and fertility and divorce. And then a final common type of transition was hierarchy-based. We often go from overviews to sort of drill down to more specific views. So the fact that these 4 types of transitions occurred so often made me think, well, maybe there's sort of fundamental or canonical types of transitions. So similar to how when we study or talk about fictional narratives, there are certain types of patterns or ways of telling a story that are just really common and thought to be more natural to users, things like chronology. So I thought, well, maybe in data storytelling, we also have these very basic transition patterns. So I thought about them a little more, and I realized that the ones that appeared quite commonly, the temporal transitions, et cetera, could be defined by just making a single change to the data model that you're showing from one view to the next. So if we think about it, a temporal transition is keeping everything about the data constant from one visualization to the next, but it's just changing the time dimension. Or a measure walk is just changing the measure. So this sort of implies that maybe these types of transitions are so common because they're only changing a little bit at a time as we move through a set of visualizations. And this made me think, well, maybe there's a cognitive cost to transitions. Some transitions are harder to understand. We've changed too much at once. And so maybe designers are sort of implicitly aware that there is this cost. So I wanted to check these hypotheses as I started to think about them. And so I did a study where I just showed crowd workers basically a single visualization followed by 2 possible next visualizations in a data story. And I asked them, well, what's the most logical next step for this data story? And I found that indeed people prefer low-cost transitions pretty much all of the time. But then that raised this second question for me, which is like, well, if cost is constant and we have a temporal transition and a measure transition, and we could use either, then what do people do? So I did a second study to figure out, do people prefer certain types of transitions when the cost is equal? And I found that they do. So there was a systematic tendency across many crowd workers to prefer temporal transitions. Kind of makes sense. We see temporal transitions and think in terms of time all the time. They liked them better than dimension or measure transitions. There was no clear difference between those two. But they liked all 3 of those better than hierarchy transitions. So changing from an overview to a more specific view was something that the crowd workers felt was a hard transition to make. So my goal in learning about sequence and transitions is, again, to sort of work towards better tools to help people design these types of things. And so I was sort of thinking about, well, what have I observed here that I could use in thinking about how I would design a tool to help people sequence data stories. So we have this principle of minimizing cognitive cost as a good thing when you're trying to sequence visualizations. And based on the second study I did, it seems that this cost model should account for preferences between different types of transitions, as well as how much of the data is changing from view to view. And so I was excited about these observations because I realized that, well, if we have a set of visualizations and we know what data is in each, if we have a system that can sort of model the visualizations on this pretty simple level, we could automatically detect what types of transitions we have and what the cost is of these transitions. And then we could basically recommend good sequences to the visualization designer. So this was sort of an idea that I thought would make for some really cool tools. But at this point, I was still sort of a little unsettled about one aspect of all this work I'd done to learn about sequence in data stories, which is that when I thought about stories as they're thought about in other fields, things like fictional stories, there's generally kind of multiple levels of structure. So we have microstructure, which is the individual events at the smallest possible level in a story, but we also have macrostructure, which is how we organize the bigger events in a story. So for example, this is a chart for a simple story about an old farmer, and the farmer is trying to get his donkey into its cage, or its barn, I guess, and the donkey won't go, so the farmer tries a bunch of things. He pushes the donkey, he pulls the donkey, then he decides that if he can get the dog to bark at the donkey, donkey, that would get the donkey in the barn. So he talks to the dog, and the dog won't bark. So then he realizes, well, if I can get the cat to scratch the dog, and then the dog will bark, and then the donkey will go in, and then the cat wants milk, and he goes to the cow, etc. And so we have this story where we have bigger episodes, like the farmer interacting with the dog, the farmer interacting with the cat, and then within each of these we have smaller events, like what the farmer says to the dog and what's the dog's reaction. And so we can organize things using different patterns at each level. We could break chronology at the high level, but use chronology within the individual events. And so there's multiple levels of structure, and I wanted to think about how this applies, sort of this high-level structure, to data stories, because my work had only looked at kind of low-level structure. And so I realized in a lot of these stories, you do see sort of thematic groupings. So here we have a bunch of measure transitions, but they're kind of grouped based on themes or topics. So here we have marriage, divorce, fertility, infant mortality. They're all kind of organized around this theme of family or parenting. And I had also noticed, when I looked through some of these data stories, this pattern which made me think of parallel structure in writing. So when we're writing and we're using parallel structure, we're taking a basic sort of mechanism like compare, contrast, and throughout an essay, we keep returning to that mechanism or that style, even as we're introducing new information. And so I noticed that some data stories do this. So they repeat a pattern of transitions. Here we're looking at different climate problems. We're looking at a sort of high-level view of each, and then we're drilling down to a specific instance of that climate problem. And the data story goes through this pattern 3 different times. And so after you've seen the first one, you sort of know what to expect. You know you're going to go from like a high-level view of a climate problem and then drill down to a specific instance. And so we can even sort of graph this out. We start with seeing the whole world and all these problems, then we pick, droughts, and then we see a specific place, and then we jump back up to floods, etc. And so I thought this was interesting because if I used my cost model to explain this, the cost overall of the entire set of sequences is actually bigger, so it's higher. So this low-level model is not necessarily going to work. And I figured that this is probably because things like parallel structure add familiarity. So we're using the same pattern of transitions, and so things are no longer surprising even as our reader is seeing new data. So this seemed like a high-level structure. And I wanted to sort of begin thinking about, as a next goal, could I create a model of narrative structure in visualization-based storytelling that would kind of reconcile these 2 levels? So we have top-down types of structures like parallel structure or semantic groupings, and then we have bottom-up types of measures like the cost between 2 adjacent visualizations. And so this is a problem I'm still working on because I think it's pretty challenging. And so recently, along with Robert actually and Heidi from Tableau Research, we've been trying to learn more about this high-level structuring. So we're basically trying to figure out how do people create groupings in a set of visualizations if they're going to then present that as a story. So we are showing people in a recent study a bunch of visualizations. They see sets of 4 or 8, and we've carefully constructed these visualizations so that people basically have to make a choice between how to group things. Do they want to group a bunch of the views together based on measure or on time? And we've constructed them so that cost is equal again, so that we can really see what kind of groupings or clusters win out. So it's a chance to learn about how people are balancing multiple sort of levels of structure and then organizing them, so sequencing different clusters that they create, both at the high level, but also at the low level. How are they sequencing the individual views within, say, a cluster of measure walk transitions? So I'm excited about this also, because I think if we can develop this model, then we really have everything we need to create cool new authoring tools that can make suggestions to someone as they're creating data stories. And if we think of things like Excel, they really don't offer any support as someone's trying to present, for instance, visualizations. And certainly things like D3 do not either. So I'm excited about that, but I'm also really excited about this other opportunity I see to use narrative patterns for analysis. So we often think, at least in InfoViz, of communication and analysis as these 2 totally diametrically opposed topics, but I actually think we could leverage narrative patterns quite a bit more than we currently do to build better analysis tools. So you can imagine someone is using a system like Tableau, and they're exploring data for the first time. They have a big data set. And we're currently seeing research on different types of features that could take a big set of data and recommend views to the analyst. So Tableau, perhaps in some future version, could say, we think you should look at these views of the data because we've detected interesting patterns in these views. And if we can do that, and if we're moving towards that, then we have this question of what path do we present those views in, or what sequence do we use? How do we sort of walk a user through data that's currently unfamiliar to them in a way that's understandable and sort of cognitively accessible? So I think that's kind of a really interesting area for future work, and one that I hope to work on, and I hope that more people will think about. So to summarize this second project, I think I found evidence that these sequential data stories do have micro and macro structure. There's still more to understand here, but the more I think we can model these things, the better tools we can create, and the better data stories. So I'm just going to close with a few thoughts. So hopefully from these projects, you've gotten a sense of what I believe, which is that we can study what human creators are doing, look at the output of their processes, and then begin to formalize criteria and patterns for tools. So we can build tools around these, and in that way, make it possible to use effective data story techniques in many more situations than we currently can. Finally, analysis needs data storytelling, so I think we should look outside just communication and think about the problems there. So thanks for your attention. I'm happy to take questions.
All right, that was a lot. So once people have recovered from their stunned silence, I'm sure we're going to have some questions.
Yeah, right.
My name's Robert. So in the first part of your talk, you talked about a tool that you had built to do measurement comparisons. What's the name of that tool? Is it something that
I don't think we actually gave it a name. So if you go to my website, you can find the stuff we've recently published on this. My student, she currently has a demo site set up, but she's working on the interactive browser application that you could actually apply to your own browser. So that is not currently released, but we are working on it, so hopefully soon. But yeah, just my website's probably the best place to check. Thanks for that question.
Jim Clark from the Associated Press.
Oh, yeah.
It's less of a question. It's not a question. It's more of a journalistic confession that I'm sure is going to appall you. I spent about 5 years working in the Anchorage Bureau. And after a while, we discovered, because things in Alaska are always big, glaciers, oil spills, wildfires, that Rhode Island was the perfect unit of measurement. And the great thing about Rhode Island, other than the seafood, is it's about 1,000 square miles. And so on the wire, time and time again, we would say it's 4 Rhode Islands. It's 3 Rhode Islands. I'm sure you're appalled at that, but that's what we did.
I think that's great. That's what people are doing, and I just, to me, it was like, well, why don't we do this? Why don't we create tools to do it so that people don't have to think so hard about what's a good unit for this huge thing or this really small thing? So I think that's cool.
Super quick follow-up to the question about whether the tool is available. Are you making the data set available of the comparison?
So those data sets, I think I have at least one on my website. The general object one, we have not published, but as soon as we do, we'll make that available. And yeah, that's actually part of this work. It wasn't what we set out to do, but we realized in doing it that there are no good big data sets of measurements. We had to scrape everything ourselves. And so there's a lot of cases I think this could be useful. So definitely will be available.
So objects and distance?
And if you email me, I'm happy to give them to you, even if they're not publicly available yet.
All right, cool, thanks.
Hi, it's Chad Skelton. I just want to thank you for your talk. It totally blew my mind.
Oh, great.
And I was actually wondering, other than obviously speaking here at Tapestry, what you're doing at UW to try to kind of get this message out. Because I almost feel now like this stuff on analogies, journalists are doing this every day, and it's completely based on hunch and probably bad hunches. And I feel like almost every journalist should now have this little index card in their desk that says, when doing an analogy, think about 1, 2, 3. Based on your research. So I'm just wondering how you get that out there.
I mean, really, talking at conferences like this is the only thing I'm doing right now, unfortunately. So, but part of me being here is to just meet more journalists and figure out how to connect more with you. So if you have suggestions on how to do that, let me know. Otherwise, I go to Computation and Journalism conference usually, and any other chances I get to sort of come to these meetups. One thing I should mention, since people were asking about a browser application for re-expressing measurements, there is a designer who made one called the Dictionary of Numbers, if you've seen that. And it's pretty cool. He did this before we did. His database, I believe, is something that he manually curated, so it's a lot smaller. But you can still get re-expressions for a number of things like prices that we're not doing.
Paula Davis with Deloitte, back here in the back.
I'm trying to see.
Back here.
Oh, thank you.
I'll wave. Just curious if there was an effect on sort of the cost model and the cost to transition based on the type of chart or graph. So sort of talked about familiarity in the first example, and I'm wondering how that relates into as you sequence things, starting with something maybe much more familiar and then moving away from it, or if you saw anything about that.
I think that's hugely important in a cost model. And what we did in our simple studies where we showed people transitions and they made choices was try to keep the visual all the same, like the same visualization types, always maps, always the same color scale, et cetera. But that's because I do think it's going to matter a lot. And so I think a next step is figuring out how to measure sort of those changes to the visual itself, irregardless of the data. So the study we're doing now, Robert and Heidi and I, we made people order or structure these visualization sets, but in that case, we took the same data and made 2 sets of stimuli, and one was map-based and one was more abstract, like bar charts. And so we're hoping that that allows us to see sort of the impact of visual similarity, because often maps, in some cases, can make things seem less similar, even when it's showing the same data than if you were showing it in 2 bar charts. So yeah, I think it's an awesome question and something that there's plenty of work still to do on.
Hi, Derek Schwab. Oh, does someone else speak?
Go ahead.
I had a question about the comparisons tool too. I'm wondering if you thought at all about beyond just looking at, you gave the example of geographic area and helping people compare things based on where they are. Have you thought about like the content of what they're reading, for example? Like if we're talking about how much the U.S. government spends on foreign aid, maybe that reader would be more interested in comparing that to spending on other government programs versus just how much overall. I'm just wondering if you thought about that.
Yeah, so the first thing we've thought about is just analyzing the text of an article to sort of pick objects that are thematically related. But I think what you're asking is sort of the bigger question, which is, how do we add context for other types of measurements like percentages, et cetera, where there is sort of, if you think about it, a clear analogy that you would want to see. I think the biggest challenge there is that you need huge data sets, so we'd have to have data on many different things. So in other projects, I've looked at sort of automatic generation of visualizations to go with news articles, where we sort of compiled a huge set of different types of economics and health measures. So I think it would take something similar to do this for those cases. I know some people have looked at generating measurement analogies for more types of measures by just having crowd workers come up with them. So that's one strategy, although ideally I think an automated system would be awesome for that. So yeah, good question. I don't have a great answer.
My name is Vanessa Raymond. I'm farther back. You were talking about sequence and decision making. I was wondering if you're trying to tell a story that isn't leading the reader to one decision, but to their own conclusion, how you would apply your work that you've presented
Yeah,
here.
I think, that's a great question. I think I was assuming in the sequence studies that you did have a message that you wanted to convey. I think maybe if you're familiar with some of the other work on narrative visualization, like Edward Siegel and Jeff Hare wrote a paper where they talked about other patterns where I think you're sort of leaving the user at the end in an exploratory phase. I think those might be appropriate. So the martini glass structure is where you sort of guide someone through a set of visualizations, but then at the end, they just get this interactive visualization, and they can explore as much as they want. So I think if you can find places where to add the sort of exploratory interactive stuff within a bigger sequence, then you can kind of balance the sort of author-driven versus reader-driven. But yeah, it's definitely a balance that has to be struck.
So this question is a little bit similar to the last one. My name is Gregory Lewandowski. So data and stories are very, very personal, or they can be. Have you noticed any kind of segmentation, right? We're in a customized world, and we segment everything. Have you noticed any specific segments that require different sequences or different narratives along the way?
I think that's what we're looking at now, really, with this study of how do people group things. And so we're actually there. We are looking at research and like how do people segment events when you're getting like a stream of information? Where do you put the breakpoints to say like now the person's making the bed and now the person is doing something else? So I think there is definitely a question about whether there are certain sort of the ways that people do that with data stories. And so yeah, that's kind of a goal of this current study. There's other work showing that when people are trying to make sense of like spatial information, there are certain types of categories that are preferred. Things like people and places are good ways to organize certain types of information. And so we're hoping that we can find sort of similar semantic concepts as they apply to data stories. But yeah, I don't know if that answers the question completely, but it seems to me that what you're asking is kind of something that we're looking at now.
Hi. Hi, CC Wei from ProPublica. I really love the sort of measurements, analogies, database situation. I was wondering, since you had taken into consideration for distance where someone is to look at objects near them, if you had also thought about when comparing actual objects in terms of size or height, the familiarity score of the object, taking into account sort of culture based on where people are, sort of objects that people don't understand. Yeah.
We only did this stuff with located measurements in the U.S., unfortunately, but I think the same method could apply outside. We just need landmark databases other than Yelp to start with, and I do think that cultural familiarity matters a lot. It obviously matters with the spatial analogy stuff where we're considering proximity, but I think it also matters for the general object analogies where, you know, certain people or certain cultures are going to be less familiar with certain objects. And so I don't have a good a way to solve that problem yet. So yeah, I would take suggestions if you have any. But I definitely, it's one that's come up multiple times, and I think it's an important next step. So yeah, thanks.
We have time for a few more. Anybody? Going once? Okay.
Hi, my name's Laura, and I'm a filmmaker. I'm wondering if you're able to look at any of the data that's available on YouTube or Netflix about when people stop and start watching movies.
Yeah, that's interesting. Yeah, I think I haven't, but the stuff I've been looking at, sort of, there's someone named Barbara Tversky who's a cognitive psychologist who studies a lot of stuff related to storytelling, like visual storytelling even. And she's done stuff where she's like shown people videos and then looked for where they say, oh, this is a new part or this is a new event or whatever. So I think there's probably plenty you can learn about.
Who is that?
Barbara Tversky. So the last name is Tversky. And her research is just awesome. She's at Columbia, but also at Stanford, so she's always between coasts. But she does a lot with visual storytelling techniques. Cool. Thanks.
Hi, Robin Kwong from Financial Times. Actually, a question along a similar vein, which is, do you think there are situations where reducing the cognitive cost is not always necessarily the goal?
Yeah, that's an interesting question.
Because if you look at the number of transitions, the range of different transitions available in film or comics, often there are transitions that require a high cognitive cost, but it's designed to achieve a different effect.
Yeah. So what kind of effects? I'm just curious. Like, it's definitely something I've considered.
So deliberate dislocation or surprise or...
Yeah, okay.
Yeah.
No,
or
it's
it might
definitely
be more of a mood type.
Yeah. So I think the study we did initially, like that was something we wanted, we felt was plausible that people might want higher cost transitions. But it may be that the study we conducted there, where we showed people transitions and had them choose somehow prioritize low cost transitions. And so I think it would be interesting to try to think of how we would study these other types or find evidence of them and how important different types are. So yeah, honestly, probably the best place to start would be talking to people like you who actually do this. But yeah, I totally think that's a possibility. And that's why I think modeling costs gets really complicated. Thanks.